Section 1.6 deals with two-dimensional figures. One important classification of two-dimensional figures are called polygons. Polygons are closed figures whose sides are segments. Poly comes from the root many, and gon meaning sides. So it's a many-sided shape. Now this first example is not a polygon because it's not a closed figure. We can see we have segments that sort of run on the interior of the shape. So that would not be considered a polygon. This next shape is a polygon. All of the sides are segments, and it's a closed figure. This next shape is not considered a polygon because this side is curved. In other words, it's not a line segment. Next example is also not a polygon because it's not a closed figure. And this final side would be considered a polygon. So again, we'll study some polygons and we'll study some shapes that are not considered polygons. Next classification deals with, well, first let's label this polygon here. We'll call it Emily, E-M-I-L-Y. I can choose where I want to put E. It doesn't matter exactly where. Maybe I'll put it right here. And now I can either choose to go clockwise or counterclockwise. Again, that choice is mine. Maybe I'll go counterclockwise. M-I-L-Y. So that would be labeling a polygon Emily. And I could have chosen any other five-letter name. Well, actually, one example could have been Aaron. The problem with that, though, is I have two repeated A's. If I introduce subscripts, A sub 1, A sub 2, then that would have been an acceptable name. Next, let's talk about concave versus convex polygons. A convex polygon is one where no interior points could exist kind of on the inside of the shape. So for example, if you were to line up a ruler along each of these sides, the ruler never crosses into the inside of the shape. Whereas with this concave polygon, we can see that we do have some points that are kind of on the inside of the shape. And we've got this sort of interior space, and so therefore this would be considered a concave polygon instead of a convex polygon. Next definition, we have some polygons that are called regular polygons. And a regular polygon is one in which all of the sides are congruent and all of the angles are also congruent. So for example, if we knew that all three of these sides were congruent and all of these angles were congruent, then we'd have a regular polygon. Likewise with this four-sided shape, if we knew that all of the angles and all of the sides were congruent, it would be considered regular. So one question that would occasionally show up is, if we knew that this shape had all sides congruent, would it be considered regular? Well, it looks like these angles are congruent. However, not all of the angles are congruent. This is acute, whereas this was obtuse. Likewise over here, and this is definitely not congruent to the other angles. So that would not be considered a regular polygon. And then finally we come to the naming of polygons. If we have any three-sided polygon, the typical name, of course, is triangle. Any four-sided shape, you might call it a square or a rectangle, but those are special polygons. We'd call those just quadrilaterals. And then we have pentagons, hexagons, heptagons, also called septagons, 8-sided shapes, stop signs, are known as octagons. 9-sided shapes are nonagons. 10-sided shapes are called decagons. We're skipping 11, not because it's not known, it's because I'm not going to ask you to know it. An 11-sided shape is called a enneagon. 12-sided shapes are called dodecagons. And any sides that are beyond the ones that are named here, we could just call those, so for example, a 15gon. Basically, any n-sided shape we'll call an n-gon. And all of these sides do have unique names, and if you visit this website, it'll give you a guide to how to properly name those polygons. But again, these are the only names that I'll ask that you will know for my class. Here's a little example problem. We see this polygon has a perimeter of 39 units. How long is each side? Well, each side is labeled as 2x minus 3, 3x plus 5, and then these congruence marks indicate that this side is also 3x plus 5. And so in order to find out how long each side is, we must first figure out how big is x. So we'll set up an equation. With 3 sides, I know that each of those 3 sides will add up to 39. So 2x minus 3 plus 2 sides that are 3x plus 5 together add up to 39. And so then we'll distribute. We have 2x minus 3 plus 6x plus 10. And then if we go through and collect like terms, 2x and 6x make 8x. Negative 3 and positive 10 makes plus 7. And that equals 39. And then we'll subtract 7 from both sides. And divide by 8. And we see that x is 4. And that allows us to solve for the lengths of each side. We'll substitute x equals 4 into this side. 2 times 4 minus 3 is 8 minus 3, which is 5. 3 times 4 is 12, plus 5 makes 17. And likewise, this side must also be 17 as well.